Hi everyone! In this video I'm going to show you how to solve quadratics by factoring. Now the emphasis on this video isn't going to be the factoring step, it's going to be the solving step. So just a heads up, the factoring I'm going to show in this video is going to be some fairly straightforward factoring because I really want to focus on the actual solutions part. So let's jump right into an a equals 1 trinomial. So let's do x squared plus 3x minus 28 equals 0. Okay, now the first thing that we're going to always need when we're solving a quadratic, you always set one side equal to 0 when you're solving by factoring. And this is because of the 0 property of quadratics. So remember in our earlier video we learned that if you've got two things, right, if you've got two things that multiply by each other to equal 0, then either your first thing has to equal 0 or your second thing has to equal 0. So that's how solving by factoring works. We're going to use this property of 0 to solve this equation. Now the nice thing here is we've got an a equals 1, right? There's sort of an invisible 1 here. An a equals 1 trinomial you can factor in one step. So you're going to get two different factors. And the way you figure out your factors is from these two numbers here, the positive 3 and the negative 28. So we need two numbers that multiply to negative 28 and two numbers that add to positive 3. So 28 is a factor of 7, so I'm going to start with 7. Sure enough, 7 times 4 works. So it's going to be 7 and 4, and then the only question is which one's negative. Well, I need to get positive 3. So I need to have a bigger positive number and smaller negative number. So it's positive 7, negative 4. So I throw that in, positive 7, negative 4, with an x in front. And there's my factored form. And so this means that the solutions to this equation are when x plus 7 equals 0, which means x equals negative 7, right? When you bring it to the other side, it becomes negative. And from this factor here, we've got x minus, well, we're going to bring the negative 4 to the other side, so why don't we just do that in one step? Right, the negative 4 on the left-hand side is going to become a positive 4 on the right. So let's just jump right to that. And there you have it. There are your two solutions. Let's pick another one. It's going to look a little bit trickier, but it's actually going to work out to be just about as hard. Just one extra step in front. So 6x squared minus 42x plus 72. And this is going to be equals 0. Now again, it always has to be equal 0. So this one's already set up for us, which is great. But the wrinkle in this one is we don't actually have an a equals 1. We've got an a equals 6. But what do you notice about 42 and 72? 42 is 7 times 6. And 72 is 12 times 6. So we can actually common factor a 6 out of this entire expression. And then what we're left with inside is x squared, because when you reduce by 6, you're left with x squared. Negative 42, when you reduce by 6, you've got 7x. And then 72, when you reduce by 6, you're left with 12. And that is an a equals 1 trinomial. And sure enough, that factors really nicely. It factors into, what are two numbers that multiply to 12, add to negative 7. Well, since it's negative 7 and positive 12, I know right away that they both have to be negative numbers because a negative times a negative is positive, and 3 times 4 multiplies to 12, and 3 plus 4 adds to 7. So it's x minus 3, x minus 4, and then we can do our solutions in one step, right? So if x minus 3 equals 0, that means x equals positive 3, right? Sort of if you imagine there being like an equals 0 here, right? When that negative 3 goes to the other side, it becomes positive. Okay, and then this one here, same thing. Our x is going to equal positive 4. And there you have it. There are your two solutions. And I guess we should throw an or in between. So x is 3 or x is 4. Okay, let's try one more. So this last one we're going to do is going to be 35x squared equals 20x. Okay, now first of all, we can't solve this by factoring right now because we don't have it equal 0. And we really need that 0 property for solving by factoring to work for us. So first thing I'm going to do is I'm going to take this positive 20x and I'm going to bring it over to the left-hand side. And so the inverse of a plus 20x is a minus 20x. Now, this one we can actually factor just by common factoring. What do they have in common? They both have a 5 in common. 5 goes into 35 and 5 goes into 20. And they both also have x in common. So we can common factor a 5x. And that leaves us with 7x, because 35 divided by 5 is 7, and x squared divided by x is x, minus, from the minus sign, 20 reduced by 5 is 4, and x reduced by x is, well, nothing left. There's no x's left. So there you go. So then you've got 7x minus 4. So you can do this the long way if you want to. The long way is to say that 7x minus 4 equals 0 from this factor. And this factor here is just x equals 0. Now the 5 in front sometimes confuses students. This 5 is never going to equal 0. So you might want to sort of think of this as a separate factor of 5 in front. Okay? So the 5 is never going to equal 0, so we just ignore it when we're doing our solutions. This x then is on its own, and x equals 0 when x equals 0. That's our first factor. And this one here in the brackets is going to be a simple linear equation from, I don't know, grade 8 algebra. So this is 7x equals 4, and then we're going to divide by 7, which is 4 over 7. And you're going to be doing this enough that you should probably be able to go from this step to this step in one go. The negative 4 becomes positive 4, and then we divide by the 7 coefficient. And so our solutions are x equals 4/7 or x equals 0. And there you have it. That's how you solve by factoring.